This lecture is about factoring binomials. So if you recall, binomials are polynomials made up of two terms. So to this point, you notice we've discussed quite a few methods. In all methods, you always have to check for GCF. If the polynomial is made up of 4 or more terms, you think of grouping. If it's made up of 3 terms, you think of using the sum and product method. And now what do you do when you deal with 2 terms? Now before we talk about the how to do it, let's try to recall something. If we have a plus b multiplied to a minus b, and what we'll do is to FOIL. A times a gives me a squared. A times positive, that's a negative. So a with negative b makes it negative ab. B with a is positive ab. And b with negative b is negative b squared. So you notice because the parentheses is 1 with minus and 1 with plus, you notice that the middle pieces, they cancel. And what you end up with is a squared minus b squared. Now getting from this direction is called foiling. What we're doing is to go backwards, and that's called factoring. So now you see the first formula, which is called the difference of squares. And what this formula is telling you is in the event if you see a squared and b squared as a polynomial, so it's made of 2 perfect squares separated by a minus, to put them in the parentheses is where you put the a and the b and the b, and use a plus and use a minus in the second parenthesis. So that becomes the formula number 1 that you need to memorize, and this formula is what you call difference of squares. So let's do a couple of examples to make sure you understand how to apply it. For example, can you factor 4x squared minus 9y squared? So you notice that 4x squared is a perfect square because 4x squared is 2x times 2x. 9y squared is also a perfect square because that's 3y with 3y. And using the difference of squares formula is going to be 1 plus and 1 minus. Now it doesn't matter which one you put first, so long as it's one of each. Okay, remember why? Because when you FOIL, you want the middle pieces to cancel. Okay, so it's going to be 1 plus and 1 minus. Okay, let's try another example. Can you factor, say, 7t cubed minus 63t? Now you notice in this question, at one glance, it seems that it is a binomial. So you would like to use the difference of squares formula, except that they are not perfect squares. Okay, so before you jump to the conclusion that, oh, so it's not doable, then you have to remember another rule that we've discussed the first time we discussed about factoring. You need to look for the GCF. So what is the GCF between 7t cubed and 63t? So you notice in both numbers, 7 goes into both of them, and between t and t cubed, you take the lower exponent. So that's my GCF. And now, if I took out the GCF, what is the reduced polynomial? 7t will have to be multiplied with t squared to give me 7t cubed. And 7t will be multiplied by 9 to give me 63t. Now the GCF that you took out the GCF, do not drop GCF. So remember this, do not drop GCF. So what you take out, you have to keep it. But t squared minus 9, if you look closely, that's a binomial, and they're both perfect squares. So you can put t and t on one, and t on the other, and then 3 on one and 3 on the other. The only difference is one is a plus and one is a minus. So that's the first formula that you need to know. Now the next one is, what's the sum of squares? Meaning, if this is a squared plus b squared, so what if it was both perfect square except that in between them is a plus? Now you notice that if you go back to how the formula came about, we chose one to be plus and one to be minus so that the middle pieces cancel. Now, if one is a plus and one is a minus, then the product cannot be plus. Okay, so you have to remember that if it's a squared plus b squared, that is prime. Okay, meaning not factorable. So take for example, if the question was, can you factor 4x squared plus 9y squared? You notice that they are both perfect squares, except that the sign between them is a plus. Then the answer to this question is that it is prime. So let's try another example. Can you factor, say, x squared plus 9? Again, they are both perfect square but separated by plus, so the answer is prime. Okay, so let's say we don't believe it. Is that true? Could it be really not factorable? Well, let's try. If we put x plus 3 and x minus 3, and we try foiling, okay, so you will find that this answer comes out to be x squared minus 9. If we put x plus 3 and x plus 3 on both, now what's going to happen when we FOIL? We get x squared plus 3x plus another 3x and then plus 9. So we do get the x squared and we do get the plus 9, but we got a little more than we bargained for. We have the extra 6x, which is not here. Okay, so if you try minus on both, that's not going to work as well. X minus 3 and x minus 3, if you FOIL, gives you x squared minus 3x minus 3x and then plus 9. So again, you do get the x squared and the 9, except that you also get the minus 6x, which is what you don't need. So remember, if you have a perfect square separated by minus, then it's doable, it's factorable, it's going to be a plus b and a minus b. But in the event if you have a squared plus b squared, then this one is prime, okay, as in it's not doable. So how can we make sure you understand? We could combine methods. Like for example, let's try a difficult one here. Let's say, can you factor what's 32y to the 5th minus 162y? Okay, so first glance, it's a binomial, meaning it's made up of two terms. It's separated by a minus, so that's good. That's the chance to continue, except that you are not perfect squares. Okay, so if you're not perfect squares, hopefully you think of GCF. And the GCF in this case is the biggest number that can divide 32 and 162 is 2. And between y and y5, I have to take out y. So I start a parentheses, 2 times, in this case I need a 16. And y with y5 is y4 minus 2 into 162 is 81, and the y is removed. So now what you take out, make sure you don't drop it. So do not drop GCF. Don't forget this, don't drop your GCFs. Okay, so GCF you have to copy. Now if you look at this one, 16y4, it is perfect square because you could put 4y squared and 4y squared. That gives you 16y4, and 81 is perfect as well because you can call it 9 and 9, and then 1 plus and 1 minus. Now this is where you are being tested. Can you stop there? And the answer is no, because if you look closely, 4y squared plus 9, both they are perfect squares, but the separator is a plus. That's when you are stuck. Okay, it's prime. But look at this one. This is perfect square separated by minus, which means you can continue. So this is where you call it 2y and 2y, 3 and 3, and then you have a plus and a minus. So you must always check your answer to make sure that you cannot go on anymore. Okay, so the difficulty about factoring is make sure to check that you have factored completely. Now let's try another example to make sure you understand. Let's say, can you factor 9xy squared minus 4x. Okay, so binomial. So you think of the formulas that we've discussed, except that you always have to check for GCF. In this case, my GCF is x. So I have 9y squared minus 4. Okay, so what you take out, please don't drop it. Now you're looking at the remaining polynomial over there, and it is a perfect square, and they are separated by minuses, so that means that you can continue. So 9y squared is where you take 3y and 3y, and 4 is 2 and 2. And then you have a plus, and you have a minus. Okay, let's try example 5. Can you factor, say, let's look at 25y squared plus 15. Okay, what can we do here? We can always check for GCF, and GCF in this case is 5. So what I have is 5y squared plus 3. And these are not perfect squares, let alone the fact that it's a plus, and so I'm done. Okay, so factoring involving binomials doesn't mean you always can apply a formula. Sometimes you're pretty much stuck at GCF. There are times when you can't even make one move, like for example, can you factor what's m to the 4th plus 81? They're both perfect squares, except that because you're separated by plus, I cannot even make one step, and that's when I say it's prime. So just a quick recap. So far we've discussed if it's a squared minus b squared, that's factorable. It's going to be a plus b and a minus b. That's called difference of squares. The second one is to say that if they are both squares but then it's separated by plus, then make sure you remember that this is prime, meaning not factorable. Okay, there's two other formulas that you need to remember. What happens if this was a cube? If this was a cubed minus b cubed, can this factor? And the answer is yes. Following the operation over here is going to be a minus b, and what you need to remember is square the first one, that means it's a squared. Switch the signs, so switch sign, so it becomes a plus. Multiply these two together, so it's ab, and finally you square the last term. So negative b when you square it is still plus b squared, and that becomes your formula. But is there a way to check? So of course you check by foiling. So a with a squared is a cubed, a with ab is a square b, a with b squared is ab squared, b with a squared is negative a squared b, b with ab is negative ab squared, and negative b with b squared is negative b cubed. So when you combine, you notice that the middle pieces cancel, leaving you with the front and the back. That's a cubed minus b cubed. And while we're at this, might as well just look at the next formula, which is where you have the cube. So formula 3 is called the difference of cubes. And formula 4 is called the sum of cubes. So is that factorable? And the answer is yes. Following the operation is going to be a plus b. Remember, this has to be opposite signs. So it's going to be a squared minus, and multiply them, and this is always plus. Okay, this one is going to be always plus because you're going to square it, so this will always be plus. Okay, so let's see us applying these formulas. So let's call this example. Can you factor, say, 8x cubed minus 27? So you notice that this is made up of two terms, okay, and how do I know it's the cube family and not the square family? Because no number squared will give me 8, okay, but 2 times 2 times 2 will give me 8. So think of what cubed will give me 8x cubed, okay, so what times what times what 3 times will give me 8x cubed, and the answer is 2x, because 2x times 2x times 2x gives me 8x cubed. What about 27? What cube would give me 27? And so that tells me that, okay, you got to be a 3, because 3 times 3 times 3 makes it 27. So these two become my candidates, my A and my B. Okay, so related to this formula that says when you have A cubed minus B cubed, then that's when you break it into two parentheses. A minus B goes into 1, A squared. So remember, it comes as A cubed minus B cubed, but when you put into the formula, it's A minus B. So in this case, it's going to be, ignore the exponent, so it's going to be 2x minus 3. And then you start another parentheses. Now how do you get the terms in the next parentheses? You square the first one, which means you have to square the 2x. So what is 2x times 2x? That makes it 4x squared. Okay, then you have to switch the sign. So remember, if this is a minus, this will be, so it's opposite sign. So if it's a minus, it's a plus. So that's why it's a plus. And then it requires you to multiply the a and the b. So take the a, which is 2x, and multiply to the 3, which makes it 6x. So this is where you take the 2x, multiply to the 3 to give you 6x. And finally, the last term is where you take the square of the 3. So it's always going to be plus, so this is always plus, and when you take the 3 times the 3, that's how you get 9, and this becomes the answer. Okay, let's try again. Can you factor, let's say 8m to the 6 plus 125 n cubed. Let's try that. Okay, so think of what cubed and what cube would do the trick. 8m to the 6. What must I multiply to itself 3 times to give me 8m to the 6? So the answer is 2m squared. Think of it like this. 2m squared times 2m squared times 2m squared. 3 times. Okay, so 2 and 2 and 2 makes it 8. M squared, and m squared makes it m6. Okay, so that tells me it's 2m squared cubed. So 2m squared cubed gives me 8m6. There you have it. Now ask yourself, how do I get 125n cubed? So it tells me, okay, I need a 5n, because 5n times 5n times 5n gives me 125n cubed. Okay, so those are my two candidates, 2m squared and 5n. Start two parentheses, a smaller one and a bigger one. Okay, so these two candidates, the 2m squared and the 5n, they go into the parentheses, and the sign over here matches this. Okay, so it's whatever the sign is. If it's a plus, it will be a plus. Okay, let's figure out what's in the next parentheses. So the trick is you square this. So 2m squared times 2m squared makes it 4m4, and that's when you put 4m to the power 4. Opposite sign. So if it is plus here, this will be a minus. And to get this next term, you have to take 2m squared multiply to 5n, which comes up to be 10 m squared n. That's where you put it over here, 10m squared n. And this sign is always a plus. And the last term is where you take the 5n to multiply by 5n, which makes it 25n squared. And that's the formula. So the cube formula takes a while. You do need to practice a little bit. Let's try one more, and then I'll get you to try some, and we can discuss the rest in class. So let's say you're given 8p to the 6 plus 1. So think of this as what cubed and what cubed. Okay, so you have to figure out the candidates. What number times itself 3 times will give me 8p6? So I hope you see that this is going to be 2p squared, because 2p squared times 2p squared times 2p squared will give me 8p6. How about 1? What times itself 3 times will give me back 1? 1 is natural choice, because 1 times 1 times 1 is 1. Okay, so these are my two candidates, 2p squared and 1. Okay, so start the smaller parentheses and the bigger one. What's in the first parentheses is going to be exactly these terms, 2p squared and 1. Use the same sign, it's going to be plus. Okay, to get the first term, you have to take the 2p squared times the 2p squared, which makes it 4p4. These are opposite signs, remember, that's opposite. And then to get the next term is where you take the 2p squared times the 1, which makes it 2p squared. This is always plus, okay, always plus. And to get the last one, you will take the 1 times the 1, which makes it 1. And that's the answer. So let's get you to try some before you come to class. These problems are from 6.3, page 278. You should be working on these problems before you come back to class, so we can discuss them if you have any problems. 9, 11, 17, 23, 33, 41, 79, 81, 83, 87, 89, 91.